right there in my face. That's better. I can see all of you wonderful gopher faces. Ooh, we got so quiet so quickly. I think that's like a record for quieting down. I feel like a kindergarten teacher. So we are going to have Chris come up. He's from Yelp. He's just going to tell us a little bit about Yelp that we don't already know, and maybe about their engineering. I don't know. We'll find out. So let's give a big round of applause for our sponsors who have an amazingly large space, so large that I was able to let every single person in from the waiting list, which has never happened before. So round of applause, please.
Hey, thanks everybody. So my name is Chris Wayner. I'm an engineering VP here at Yelp. We're huge Go fans. I'd like to say welcome and really glad to have you here. If you're interested in a little bit more, knowing what we're up to, we have our engineering blog is at yelp.com/engineering. Please do check it out. There's a few of us floating around, myself and a few engineers here from Yelp who definitely actively work on Go. We also have Julia back under the neon sign in the back. We'd love to hear from you. We are actively hiring and really hope you guys enjoy the evening. Cool. Thank you.
Thank you. All right. So you know me, and if you don't know me, then you will soon. I'm Cassandra, and I like to just jump right in. So we're going to have Quinn from SourceGraph. He is co-founder and CEO. Come up and give a lovely presentation, but I'm going to stall a little bit more maybe. Do you want to turn your computer on and everything? Cool. I like the support. Oh, and we are live streaming this event. So let's just go over this while you guys are paying attention to me and gals are paying attention to me. If you have a question, I really need you to clearly raise your hand after, and I will try to run to you. And if you know it's ending and you know you're gonna have a question, you are welcome to raise your hand. Unfortunately, I don't like these to go too much later than I promise our host that it will go, so I may cut you off. Try not to get too upset with me. Did I stall long enough? Okay, cool. We're ready. Quinn's ready. All right.
All right. Unmute it. Unmute it on. Okay. All right. Who else loves these video sharing things? Just gonna find out how to attendee. Oh. Great. Testing. Good to go? All right. I love the companies that say that we've fixed video conferencing. It's a tough claim to make. So thank you all for coming, and it's great to be back here. I have, recognized a bunch of people in the audience. We have a bunch of users here, a bunch of friends, customers, and so on. So I'm excited to run you through how we think about building better libraries in Go and share a new thing, a new tool that's released. It's actually already been released. So the fact that you all are sitting here means there's probably someone who's gone and seen it already, but you'll get it 10 minutes from now. So run you through. This night is all about how to. All the other talks are about how to do things, and I want to start out by just talking about why is it important. Well, let me start out by fixing the alignment on this. There we go. That'll do. All right. So I want to start out by talking about why. Wait, the alignment is still not good. There. All right. We need a company to fix presentations. So why does better code matter? I mean, after all, your code compiles probably. It's making money for you. It's solving problems. And it might have even helped you raise money here if you're an SF, because that's all that matters, not making money around here. So why does better code actually matter? Another way to think about this is, well, why does the environment matter? If you have a factory and it's making a lot of widgets, then, why does that matter? If you think about the world's code ecosystem like an environment, when you write bad code, you're actually polluting it, and you're causing harm to other people out there. So, why does the environment matter? It matters because there are other people out there who you're affecting. There are people who are using your code. There are people who are going to have to maintain your code. There are people out there who are learning Go for the first time, and they're going to read your code, and you want to make a good impression on them. And by the way, this other person might be you in a year, and you are going to wish so badly that you had spent just a little bit more time to write better code. So, it's one thing to say, oh, we should all just write better code. Let's just be really conscientious. But it's not that easy. You can't just fix the environment, make pollution all go away one day by just saying, let's stop polluting. With code, it's not as easy as just saying, let's all write better code. Let's be really thoughtful. Let's think about all those other people out there that are going to see the code, and let's be really nice to them. No, the fundamental problem is that you all have finite time, and there are a bunch of things you could do to fix your code, but you don't know which things to do. So what I think about when I think about how do you write better code is not just this abstract question, but given that you have 10 or 15 minutes between a meeting and lunch, what's the highest impact thing that you can do to write better code? And that's something that is actually really hard to answer right now. You can run a linter and it's going to tell you 9,000 things wrong with your code. You could go and ask your teammate and they're going to probably have tons of opinions, but it's really hard to answer right now. So we think about code as data at SourceGraph. It encodes all these things like what is being used, who is using it, what is working, what's not. And that actually has the solution to this problem of you have 10 or 15 minutes and you want to know what's going to be the highest impact. Well, the code can actually answer that. So I'm going to run you through a tool that I built that is completely local that helps you answer this question. And then we will run through some actual projects, some that people have submitted, some that we're just going to go on, and some that you in the audience will suggest. And we're going to make some fixes using this tool and show that with just a little bit of time and data, we can have a high impact fix to these projects. So this tool is called Used. It's available on GitHub right now. And what it does is it goes and sees what are the most called functions, essentially. So if you have one main function and it's called like 20 different times from other packages, then that's kind of a hotspot. And everything that function in turn calls is a hotspot, and so on. And so if you do this traversal of all the calls in your program, then you should prioritize fixing the code that is likely to be run the most. If you run a linter, it's going to print out 9,000 things. Most of those are probably going to be on test code or things that you don't really care about. You want to just get to the high impact things. So this tool will show you that, and it also take linter output and actually chop out the things that really don't matter because they're not actually being run, and it will also prioritize the things that you should go fix that are highest impact. So the goal of this tool is not to solve all of the problems with better code. It's just to show that with the data that already exists in your code and the call graph that your code has, you can do some pretty interesting things to make it so that you're cleaning up this environment of code and this world of code. And let's jump in. So we'll go through some of these projects and actually show how you can make data-driven decisions to go and fix things better. And then if you have a project, anyone here, that we should go through, then think of that, and I'll ask for some audience input in just a few minutes. So let's jump in. We are doing it live, so pray to the internet and Wi-Fi gods and all of that. So who here has used Gorilla Mux? Okay, most people. So even a relatively small fix multiplied by all these people in this room and across the world would have a pretty big impact. We actually compute stats like how many people use libraries at SourceGraph, and we know that just in open source, there are at least 3,100 projects using Gorilla Mux. So even a small fix would have a pretty big impact. So I am going to use this tool, and let me resize the window a little bit. There we go. Going to go in Gorilla Mux, make it a little bit bigger. All right, and let's just run a linter. One of the things that you could do to improve code is just to run a linter. All right, well, it's got, a fair number of things that we could fix. So, that's good. There's a relatively small library, and we don't really know if we just had 10 or 15 minutes, which one should we go do? So the first thing is we can use this use tool to just say, what are the most called parts of this library? So here, we can see it looks at all the Go code, and this path field, the path func is used a bunch. New route, I think we've all probably called new route at some point or another, used 61 times, and we can kind of begin to see the hotspots. And so this is where you could take 5 or 10 minutes every day and just pull this up and go down the list, and every day just make one of these definitions a little bit better. What you can also do is you can take that linter output that we saw before, and you can just pipe it through this tool used, and then see what is it going to prioritize for you to go fix. So it's doing a bunch of code analysis. This is all local, by the way. And basically says, here's some pretty commonly called functions that are complex. Has anyone actually used a cyclomatic complexity detector? Wow, that's a fair more than I thought. But we don't have a lot of time in this talk, so we're not going to go through and fix the cyclomatic complexity of this function. That has something to do with how many branches does it have. We'll take an easy one to fix right now. So I'm going to disable that. And it's thinking. OK. So basically it says there's a relatively commonly called definition that doesn't have a comment. So let's go fix it. Just pull it up. And it's in route.go, line 44. Here it is. So, at least 3,100 users who encounter this. They have no documentation. Let's help them out. So what does skip clean do? Well, I looked ahead at this one. The other ones are actually live. So do something like that. And then, boom, that's it. So now if we run this again, then it's going to show us another important thing to fix. And we can just keep going down the line. And eventually we'll hit 0. But it's most important to fix the highest impact ones, not all of them. All right. Next one we do, we'll actually submit a GitHub pull request on it. So we'll do it live. And I'll turn the computer around and we'll take a little photo to include. So I'll submit this one later. You all can go and +1 it. So this is another project, and this is someone who actually submitted their project to be reviewed at this talk. So this person is expecting us to go through and pick apart their code, said that we can be as mean as we want, but we'll be pretty nice. This is dgit, which is a library that has all of Git's functionality, or most of Git's functionality written in pure Go. So pretty cool library, and I think the reason this person wrote it is because to actually understand how to use Go, you need to re-implement it in a couple languages. So that's what he did. We will pull this up, and let's just run the linter again, because again, that's what exists now. Anyone could go do this, and the fact that linters exist doesn't mean that there's no bad code in the world. I don't really feel like going and fixing all those things. I just want to know what's the most important. So we can use the little tool again. Let's take the top, 20 and let it think. Okay. So again, it said of all the things that are called the most, what issues do those have? And we can see some actually potentially bad issues. There's this one Go linting tool that says, did you assign to a variable and not actually use it? And it's actually kind of bad if you assign to an error and you never actually return the error, because then the caller is not going to know. So let's go fix this one in cmd/diffindex. Okay, it's on line 16. And sure enough, here's an error, and we never actually return it. So this error just gets swallowed. That's how you have a bug, people. This is a bug, a real live bug that we just found. We would not have found it if we just had that like 9,000 line, thing of errors. So I think we can probably just do something like that. It's the classic Go error handling move. All right, we got our little diff, and actually for bonus, let's go fix the other one in diff tree. Diff tree line 51. Here we go. Similar thing. Everyone who says error handling is hard in Go, I mean, seems pretty easy. Yeah, exactly. Well, now you have this, so you can always remember to add it. Okay, so let's go submit this up. To prove that this was done live, you can see I don't even have a fork of it. All right, I'll push this up to my fork. Not master, you got it. All right, there we go. Okay, get ready to smile, everyone. And for everyone who's on the video, sorry you won't be in this one, but you can go add your own photos to this if you're watching this from afar. Let's see. I might not be able to get everyone, but smile. Beautiful. It's pretty late in Montreal for this guy, and just imagine the shock he's going to have when he sees this. All right. I will go on and write more of a description later, but I don't want to keep you all waiting. All right. There we go. That was fun. So we probably, saved him a few minutes down the line. Maybe some user would be using this, run into a bug, and we just save that user. Super quick. And believe me, we would not have found that if we just had to go through all, 9,000 errors that it threw. So let's take some audience suggestions for libraries. And I only want to pull up libraries that people here created or maintained. Okay, sounds like we got some takers already. The library itself? Well, that would be ironic. Yeah, let's do it. All right. Actually, let's do the full output first. And I want someone else in the audience to go fix it, not me. So it's got a fair number of issues because, again, my time is finite. I'm not, the perfect person who creates zero code pollution, but let's see what it suggests that I fix. Please don't have any issues. Yep. So I have some things that I should go comment. I know, given that it's about 10 minutes old, not that many people are using it now, so as long as I get to these by midnight, then I think we're good, right? Let's get a library that's out in the wild and go run this, that someone here created or maintains. Who's got some suggestions? Does anyone have a Go library up on GitHub? Has anyone here ever written any Go code? No. Are we at GoSF or is this JavaScript SF? All right, well, I have some other ones that we can go to. Yeah, we can do Caddy. Yeah, Alex? Your wife has a library. So This depends. Is this like a my friend committed a crime thing, or and it's actually yours? Is your wife here? All right. Why don't you go home tonight and say, hey, honey, I found this great thing. I found some problems in your code, and yeah. I have not used this on my wife's code. She writes some SQL, and it doesn't work on SQL yet, so that's my excuse. Let's run it on Caddy. Matt Holt, he's the creator of Caddy. He's a good guy. He's very nice, and I think he'll have no problem with us doing this. So you got to make sure that all of the dependencies have been gotten, which I believe they have been. There. So let's just see what it would be like without prioritization. Oh, Matt, you're killing me here. All right. Oh, there we go. So again, no way we're going to go fix all those things. Let's take pop 100. See if we can fix something. Who here uses Caddy? Okay. Good number of people. All right, so let's look through. And some of these, again, don't make sense for us to fix all here together. But this is kind of a boring error. Basically says you use a string multiple times. You can disable some of these with Go meta linter, which is an awesome tool. Just a bunch of those. All right. We get some unnecessary conversions, but that's not good. I think that some of these errors are not actually that interesting, period. So let's just say we don't want those constant issues. By the way, Go meta linter is a very cool tool. It runs like 15 linters, including things that you had no idea were even a problem. All right. Let's see what we got here. So there are some security things that it's found in relatively commonly called parts of the code. So this is GAS. This is a Go AST scanner, which does a lot of security checks. But we have limited time here, so let's fix an easier one. Got a file permission thing that just says, oh, you shouldn't ever have anything higher than 0600. All right, some more security things. All right, here's one that we can fix, or this one down here. So it's right in the setup function and setup line 172. Okay, so it's this little bit here. It basically says this is unnecessarily verbose, and we can simplify it to just that. So relatively small change. We'll see the diff. But we just made the world a better place, right? That's what we do here in SF. So let's commit this one. I'll go fork it. And when I'm done with this, I would love for someone to have an idea for a library we could go to. We'll do one more. Yeah? Go torch? Okay. All right, I will submit this as a pull request later. Let's do go torch. Uber go. Like that. Cool. The demo gods and internet gods are treating us well so far. All right, So let's see what it reports without any kind of prioritization. Okay, so this might actually be a pretty good library, not a ton of things. Let's see of these what it does prioritize for us. Let's see the top 5. All right, so there's a security issue. Basically just wants you to say, I know that I'm launching this subprocess with some user input. Same thing there. There's a complex function, unhandled error, and shattered declaration. So let's take a look at this unhandled error, line 67, stacksample.go. Okay. So this is just an unhandled error. I don't know if I have enough knowledge to fix it, but the point is the person with the knowledge to fix it could go run this, just do that every morning between a meeting and lunch, and they'll make the code better. So you can go do this. And when you make the PR, then just report back. All right. So there's a lot more that you can do by treating code as data, obviously. You can get a lot more complex in this. You can do analysis to see not just what are the most called things in this one repository, but across all of my company's code or across all of the internet. And obviously some of that stuff that we're thinking about is source graph. This tool is completely local for all you to use. And I hope that you find it useful. Hope that you start thinking about what other things can I do that takes advantage of the fact that code encodes all this human activity, all this history, all these relationships from things. And if there are any other libraries that people want to try this on afterwards, then I'd love to see the output on it and see if it's actually useful in what you come up with. So that is how we think about building better code. It's not just go be a better person, just think about all those people, just write better code. It's, be realistic and just do what you can and prioritize it in the right way. So thank you, everyone. And we can have a little bit of time for questions if there are any.
Any questions online? No. Any questions in the crowd? No. All the time you get. Thank you so much. All right, we have an announcement from Sarah, who's the founder of Women Who Go.
Hello. Hi, my name is Sarah. I'm a software engineer. I work on the Go team at Google. I also started Women Who Go. I started about 2 years ago. We've got about 18 chapters around the world right now. And you can see by looking around the room why we need it. So I'm fundraising right now for trying to get women who can't afford to go to GopherCon to go. I've raised about $25,000 so far. I've got a crowdfunding project that you all should donate to. You can find the link on womenwhogo.org. And please give us money. Thank you.
I definitely would like to see more women at GopherCon this year than what I saw last year. I'd like to see more in the room too. So if you ever have someone that you can bring, then bring them. And if you're able to bring a woman with you or another minority or a person of color and you guys are stuck on the wait list, then you're always welcome to ping me because I'd like to see this room a little bit more colorful. Okay. Konrad is ready.
I think so, yeah. Okay, cool.
Maybe.
Almost.
We're still
almost.
debating. Ooh, right in my face again. All right, so let's build a concurrent non-blocking cache. Ooh, I like that. Are you all set up on Good, good. We're
Yeah.
online. We're live streaming still, and it's going really well, right? We've had no problems, no connectivity problems. Some of you remember what happened at Lyft a few months ago. Yeah, I know you do. All right, round of applause for Konrad.
Cool. Hi. My name is Konrad, and I want to talk today about concurrent data structure design in Go. In particular, I want to build a concurrent non-blocking cache. And the question really is, what is a cache to begin with? Cache, I mean, concurrent non-blocking cache doesn't only sound very sophisticated, but it actually solves a real problem. For instance, imagine we have a service makes requests to a server, and that server, in order to compute the response, needs to call some slow function. So that's a very easy thing to optimize, right? So we can just use a cache and pre-cache the value and then deliver the results, which would make subsequent requests a lot faster. That's a very simple thing. And you could raise the question, why should I bother in building something like this? I mean, surely there are a lot of libraries out there who have already solved this, right? I mean, like code reuse is a thing. And not invented here is, yeah, it's kind of a disease, right? I mean, it's fun to write your own code, but it's actually also really good to reuse code. And so, yeah, why should you not just go out there, pick a library which already implements this and use it? So there are actually a lot of things, and let me get a little bit into this. So for one is sometimes the lack of type transparency when you try to make libraries and try to make them as generic as possible, but also accessing the underlying data. So let me explain this maybe a little bit. So for instance, given we have like this deck here, deck is a double-ended queue, and since the library tries to be as generic as possible, obviously the value it would accept would be the empty interface type. And the empty interface type is great. You can just pass everything to it, but it also tells you absolutely nothing. So every time you want to access the values, you need to do type assertion. So that's a little bit bothersome. I mean, after all, like, nice thing about Go is static typing, so why give it up again? And if we want to be like very pedantic here, we should actually also check if the type assertion is successful. So these kind of things add up to libraries which try to be super generic. Another example is when you want to use it, for instance, for persistence. So let's say you make it as part of a struct and you want to persist it, and then you see that basically the default JSON marshalling doesn't return anything at all, and then you start investigating and you see, well, of course there's nothing to be marshaled because all the fields have not been exported. So one easy solution would obviously be like start wrapping this data type again, trying to make the data you're interested in accessible in another way. But the thing is really, why should you reuse a library then in the first place if it doesn't really fit your need? In a way, I think where Go really shines is like writing code and making it very specific, capturing your problem solution. So I think that's actually a great reason why you should know how to implement these things on your own. So yeah, let's jump straight into it and implement such a cache. And I want to talk a little bit about what kind of gotchas you need to look out for when dealing with concurrency. So let's start a new project and start implementing this cache. So what we would have is our own cache struct, and we would store the values using a map. We use string keys, and we define the results in another struct. And that's actually a compound value because we want to return bytes, but also want to have the option to return optional errors. And then we want to at least allow some flexibility, so we define function type, which we can pass to the cache function, which then get used in order to compute the value. So then we need a constructor. that was welcome to the party. So what do we need to do? We need to instantiate the map, to make a new map, result. Okay, so now let's get to the actual function of the cache. So we want to get something, the key defines where the value should be stored. Yeah. Oh. This better? Yeah. Okay. Is it too small in the back? I will access. Okay, cool. So then return. Okay, that's a return signature. Okay, so when we get the value, what do we need to do? So we want to return the result. So we access a map. And we also need to check if we actually got a value. So we can use a second return value in order to check that. If we are successful and the value has already been cached, we can immediately return it. And if not, we want to create a new result entry. And we assign the value now finally by actually calling the function. And then insert it. Okay, that should hopefully work. Let's check that actually. So I've prepared something here. Retrieve an actually cache test out of my magic box. That cache test looks as following. So in order to test this, we will use, so our slow function in this case will be an HTTP get body function. It basically will call a URL, will retrieve the body, will read it as a whole and return it. That's exactly what we want to cache. We have a list of URLs. These URLs are actually, there are actually 4 different ones, and we will retrieve them once more in order to test the cache capabilities. And for that, we will run the test. And actually, we will begin with just a sequential test. Okay. So as we can see, basically here, these URLs have been retrieved. It took like millisecond up to a second, but you can see down here that actually nanoseconds. So it was a lot faster getting the same URL the second time. So that at least is working. Now, network I/O is a classical example where you want to apply optimization, right? You want to run it concurrently. So we look at the test again. I've written test concurrent, which will launch Go routines to basically call all of the URLs at once, launch 8 Go routines, and then they all compete for each other for the cache. So let's try this. Okay, so this was a lot faster to begin with, but we can see that like, even though some of them have been retrieved second time, it took a bit longer. If you know a little bit about concurrency, like it should be obvious that like we didn't apply any synchronization whatsoever. A great way always to check like if there are synchronization issues is to supply the -raise command to either your Go test or you can also compile your Go binary with this addition. And that one will check for race conditions. Okay, this didn't work. So this is actually, in a way, good that that happened because -race can detect race conditions, but it can't prove the absence of those. So you should, when you use race, you should definitely make it part of your continuous integration chain because sometimes it could be uncovered, sometimes it couldn't. Oh, actually, now it worked. So here we got a data race. And if we now look in, we see cache line 23 and another write as well in line cache 23. So basically, Go routines are running, trying to write back the same value for the same URL into this line. So how do we apply synchronization? I think the easiest solution is always we just serialize the access. We add a mutex, and what's very common is basically then to log at the beginning, and then it's also very idiomatic to call unlock right after with defer so we don't forget. So that should have fixed it, but on the other hand, we're applying quite coarse locking. So running this, I mean, the speed is okay, but like it's still not that good because we're basically, this is called monitor-based synchronization. The whole function is being locked, and in a way, this is exactly a blocking cache. And let me now actually go shortly into detail what the difference between a blocking cache and a non-blocking cache is. So while a blocking cache, when you get a miss after a cache request, the cache must wait for the result of the slow function, and until then it's blocked. That's bad, right? Basically want something which is like a non-blocking cache. A non-blocking cache, on the opposite, has the ability to work on other requests while waiting for the result of the function. And we can achieve this quite easily. I mean, in a way, you never want to like block the whole section of the code you want to synchronize, but only the critical section. The critical section is that part where resources are shared. So in that sense, we want to lock around here because here we are accessing the cache. And we want to lock around here when we write back. So as we can see, this has improved speed quite a bit. Lots faster now if we compare the numbers with before. There's still another gotcha. So maybe to make this visible, let's go in here and actually print the URL which is being fetched, which should really only happen like 4 times. But if we make this visible, then we can see that like some, or I think even all of the URLs are still being fetched twice, right? This is not great. Like, I mean, yes, we want speed improvement, but at the same time, we also don't want additional network I/O because that's also the point. We become much more resilient if we like reduce any kind of I/O. So the next optimization to this cache would be called duplicate suppression. And in order to achieve that, we can actually make use of channel. So for that, we need to change the whole structure a little bit. We will introduce a new type called entry, and entry will actually wrap the result and will also hold a channel of the empty struct. Having a channel with the empty struct is basically a convention in Go. If you just want to use this channel for signaling, basically a signal-only channel which doesn't transport anything, but which you'll just use for broadcasting things. The other advantage is that channel of the empty struct also compiles to 0 bytes, so that's actually quite handy. Okay, so we changed the general structure here. We will just get rid of all of this here, so I don't confuse myself. So we begin again by locking because, again, at the same time, we want to see, we get a GET request in, and we want to check, is this already there? And then we need to check, well, has this entry been created in the first place? And if it hasn't, we will create a new one. And now we need to make the ready channel. And we will store it immediately in the cache. So we are doing a writing operation, so it's good that we still have the lock. Now we can unlock. And no, let's finish this first. Okay, so now we actually want to insert, basically call our slow function. So the entry has already been created. It's already in the cache, but at the same time, it's not accessible until we close the ready channel to signal that the value has been computed. So basically, if we get a GET request in and the entry is not null, then that doesn't mean that the value has been computed yet, but that maybe has been computed, but at least that something is in progress. So what we want to do is we want to wait on ready condition to happen. And actually, we can unlock right after here, because we're not doing any operation. And when it is ready, well, in that case, we can then actually return the results. Okay, let's check this. Okay, it's 20, 21. Okay, most importantly, what we can see here is now every URL is now only being fetched once. And that's exactly what we wanted. So it's basically a combination of log. So we still have a monitor-based synchronization in order to access the map. But at the same time, we're also using a channel to signal and transport that communication value by waiting on it. So what's important to point out here is that's just one way to implement it. There are a couple of other goes you can have on this kind of design. Just to show you something else, you could also replace this monitor-based synchronization by just using a log. You could just use channels, right? Because you can implement logs with channels and vice versa. And just to give you an example of how that could look very different, cache, which is just done with monitor-based solution, with panel, which is where the map is basically defined by a channel monitor. So the cache now doesn't have a map anymore, but instead it has a channel of incoming requests. A request contains a key. It contains a channel for the result. The entries are still the same. And in addition now, when we create a cache, we also start something called cache server. And what does get now? Get basically creates a new response channel and makes that response as part of the request, sends it down the request channel, and then we'll wait for the response to be calculated so it can return it. So now all the meat is actually inside the server function. What happens here? So now, as you can see, actually our cache is now confined within a Go routine, which is constantly running over new incoming requests. And then the code is quite similar. We check if there's already an entry. If not, we create a new one. We put it into the map. Then we make call, which is basically the code we've seen before. It's calling the function. Then it gives a signal that everything is ready. And then it falls through to entry deliver. And entry deliver does the same as before. It waits on the channel to be ready and then sends the result down the response channel. The go statement here is important because otherwise it would just block and no other requests could be processed. So this should give like quite a different take on how you could also structure the synchronization. I think a lot of people come to Go when they start using it and get to learn to use a channel as a concurrency primitive. They start to use it a lot because it's just very handy and it's in a way also very simple to use. But I think depending on the problem you're solving, sometimes a different concurrency solution can capture your problem much, much better than a different one. So it's good actually to know how they work differently together. And so there are a couple of other things to look into, like this is just the beginning, right? If you think about it, you also want to have like actually an expirable cache. So the keys you put in there should have a time to live. So you could in addition also add cleanup go routine, which basically runs over those. And in my work, as I've implemented these kind of things, you will notice that the more you add, the more interesting it becomes. So maybe just one really interesting gotcha, which can be quite mean, is the following. Let's imagine, because usually like slow functions are not always as simple as that, but let's imagine one of these methods would panic. And let's say we only want this to happen on this URL here, actually. Right, so, and then in addition, we need to modify the test a little bit, because if it would notice a panic, it would just bubble up immediately. In a real world problem that wouldn't quite occur, the Go routine would just panic and your server would still continue. So if we check this now, then what happens basically is it retrieves one of the URLs the first time, and then it will panic, which crashes the Go routine, and then the second time it tries to retrieve that value because it requests it again, it just blocks forever. And that's actually quite mean if that happens. So, and if you think about it, like what happens here, so basically here the function is called, right? And if it crashes there, it just dies, and it never reaches this point. So that should really never happen. So in a way, what you want to do here is, I think that's actually a great use of recover, where you can recover from panics. So if that happens, you want to basically clean up the mess you left behind. So let's see if that actually fixes it. Okay, so here it could pass it. I mean, in general, you should also rethrow the panic, but I hope you get the gist. Yeah, okay, to recap, basically, you can use the -race to uncover data races. Definitely should be part, at least in my opinion, of your continuous integration chain, because there will always be code edited which might not be as bulletproof as you think it is. And these things can definitely harm your production system as well, because they might not be obvious in the first place, but can happen later. Then I showed you monitor-based synchronization by using mutex. Didn't talk about read-write mutexes, but you can also use them. For instance, you can, if you're just reading, you can just use reading logs. Then we improved the solution again by using something called duplicate suppression, by using a signal-only channel. So in addition, we use the channel to communicate. And I also showed you the alternative design, confining a map just using a monitor Go routine solely with channels. I think the important part here really is there's like a very strong variety of different solutions, and it's really interesting to explore them, all these different, because depending on the solution you're picking, the expressiveness can vary a lot, and like based on that can also reduce the cognitive load a lot. Cool. Okay, thanks.
Are there any questions? 1, 2, 3. No? Okay. You're out of time anyway. So, while Bill gets ready, speakers, if you have slides, if you could make those slides available on the meetup page, that'd be great. Unfortunately, Konrad, the last tail end of your talk got cut off, so people didn't get to see it, which is kind of a bummer. I am creating I'm so tired. Like, this is me. The coffee is done. I even had like a Coca-Cola, and that didn't work. Beer probably didn't help. I'm creating a paper call, so a CFP essentially for GoSF, because this is a very large group and we get so many meetup messages, and it's really hard to organize it and manage it, the amount. So at the end of this, on my Twitter, Cassandroid, like Cassandra and then an oid at the end, I will post it because I'm literally doing it right now. And if you have any talks, lightning talks, full talks, etc., that's going to be the new way to go. And I will also be emailing the meetup group about that. So just thought I'd share kind of what I'm doing as my way of stalling while Bill gets set up on the live stream. What else can I share with you? I'm sure there's a lot I could share with you about my personal life, but you wouldn't be interested in that, and that'd be kind of awkward because this isn't a therapy session. I thought it was funny. All right, we're almost ready. Has anyone ever used the live stream from like home at all? Yeah? Yeah, yes, of course you, yeah, that makes sense. And it was okay. Don't tell me, I don't want to know.
What do you want me to log in?
I got nervous all of a sudden when I asked you that. I was like, no. I want to believe it's amazing. The live stream is something pretty freaking rad, and we would like to keep doing it, but it is a GoBridge initiative. So it is something that, well, actually, the three of us, ironically, are in GoBridge, and it's a volunteer-based process. However, Big Marker does cost money. So if you have a company that may be interested in sponsoring an amazing initiative like live streaming all meetups that are Go related and all talks that are Go related and tutorials, because it's not specific to GoSF. They use this for a variety of Go related talks. Then feel free to contact one of us. We also are on the Go for Slack channel under GoBridge, so you can find us there too. But I'm going to be reaching out to companies probably in the next couple weeks, as will Gujan, to try to find people to sponsor. It's not really that expensive, but since we don't have money, we have to find someone to give us some. So
Money, Matt. I hate asking for money.
I don't mind it. Clearly, I just did it. So
Wow.
Are you ready?
Yeah, we're going to jump on his laptop. I just got to move over to
We're almost ready. Oh, whose first time is it here at GoSF specifically? Wow. I think that's one of the larger first-time numbers that I've seen. Okay, something else I can do to stall. Who has traveled the furthest to be here? In other words, who's from somewhere really far away? Someone's pointing at you. Bill, well, yeah, but you know what? I bet someone could beat Bill.
Oh, easily. I'm only Miami. That's not that far.
I bet someone
Come
could
on
beat
now.
Bill. Who else? Did I see a hand over here? Really? Where? Berlin.
You're living in
Wow,
Berlin
Konrad
right now.
is from Berlin, so.
There you go. See, I told you.
All right, Bill's been beaten.
We got to bring some energy up in this room. Let's go now.
Wake up.
Come on, everybody's just drinking a little beer, right? You're drinking some beer. All right, come on. You know, I guess you guys are spoiled. I go back to Miami, and my office doesn't even have peanuts. Okay? Nonetheless, beer. I always tell these kids when I'm in university and they're about to graduate and they want to go work somewhere other than San Francisco, I'm always like, dude, you know, you can move to San Francisco. You don't mind sleeping on a couch, and you get to eat and drink beer every night. There's a meetup happening in San Francisco almost every night, right? All right, just about. I mean, who cares if you don't care about Mongo? They've got a decent spread, right? Could also be a cheap date. Come on now. I mean, you're sleeping on a couch. You're not bringing her back to your couch, are you? I really love that. Oh, I think we're about to get going on here. I'll just fix that screen there. This is the craziest room I've ever had to give a talk in. I'm not going to be over there. Are we ready? We got okay. So first thing is I do not like slide decks. I'm just ridiculously horrible at them. Next thing, and this mouse is so sensitive. It's going to be really fun. Okay, I only got half an hour, and if you know me, or if you don't know me, I just like to talk. So let's get to it. I go around the world. I do a lot of training. My name is Bill Kennedy. I know I'm really bad at introducing myself. Maybe we'll figure out that later. But one of the biggest problems that I see in almost every shop, and it's not anybody's fault, is that a lot of projects are either failing or having to get rewritten or restructured because of bad packaging decisions. And it's not really anybody's fault. Packaging in Go is something that's very unique. We haven't really learned how to do these things yet. And so what I want to start doing is thinking about how can we structure our applications and think about package design in a way where we can be more successful in the beginning. Because, think about this. Every project you work on, one of two things are going to happen. It's either going to fail or it's going to become legacy code. Agreed? And we all want our projects to become legacy code. But I'm telling you right now, what's going to bring down humanity, what's going to bring down all of society is all the legacy code we have out there, because who wants to maintain it? And at the end of the day, who can? And that's what's scary. I had a CEO one time ask me, so what keeps you up at night? These questions keep me up at night. But no, reality is legacy code should be keeping all of us up at night. So I want to make sure that the code we're writing now is going to be legacy code 3 to 5 years. 3 to 5 years legacy code, right? That's the idea. Think about it. If we are not refactoring our code on a constant basis to keep the architectures and the designs up to date as our systems grow, then yeah, everything's going to crumble over time. And you got to love this screen right here, or we got them over there. Okay, so I want to talk to you about package-oriented design. We're going to talk about history, some language mechanics, and eventually I'm going to give you a project structure that's been working for me, and hopefully you can go back and start thinking about it, because this whole talk's about one thing. It's about you starting to think about what you're doing, not doing it blindly anymore. Be able to answer questions. Think about what you're doing, not just for today, but for tomorrow. So here's package-oriented design. This is my definition of it, right? It's going to allow a developer to identify where a package belongs in a Go project. It's going to also dictate what the design aspects of that package is. But I think most importantly, it's going to allow each and every one of you, individually and on your teams, to really start to communicate about clean package design in your applications. It's going to slow you down just a little bit. But I promise you, you'll be running much faster later on as that project and as your team grows. Now, it all starts with a little bit of history. Back in the year 2000, Brian Kernighan, I don't have to tell you who he is, right? Was asked this question: can you tell us the worst features of C from your point of view? When I read this quote for the first time, I almost fell out of my seat. I think that the real problem with C is that it doesn't give you enough mechanisms for structuring really big programs, for creating firewalls within those programs so we can keep the various pieces apart. It's not that you can't do these things. It's not that you can't simulate it. Of course you can. But it is the language not giving us any help. Think about this. This was the year 2000. Right? When did they start even thinking about and developing Go? 8 or 9 years since then. Rob Pike and Rob Griesemer and these guys, they know this stuff because they've been doing it for 40 plus years. Nothing in Go is an accident. Everything in Go is built on a history of mistakes that were made. And guess what? Go's not perfect. It has warts. It has mistakes. And the next language that comes out 10 years from now is going to improve on this one. And I hope we're all in the room being able to take advantage of that. But what's the big thing here that Brian is saying? That the compiler and the language isn't giving you any help. That this has to be part of the language itself, not just the tooling. That's amazing. So now with this history in mind, I want to go through the language mechanics here of packaging in Go, and then we can talk about design. I always equate this to the idea if somebody's never seen a hammer before, we could talk about the history of why it exists. We can teach someone how to use it, But then through design, we're going to teach somebody how to use it effectively, depending on the situation that they have in front of them. And this can't be about patterns. It can't be about taking some pattern off the shelf, because every day we all hit new scenarios that we've never seen before. We got to be able to think through them for ourselves and discuss them as a team. So let's go through the language mechanics that we have here for packaging. And they fall into the 6 bullet points right here. The first one, packaging directly conflicts with how we've been taught to organize source code. Think about it. We've been taught to use our source tree folders to organize the source code that we write. But we can't do this anymore, because every single folder in our source tree in Go is what? It's a static library. Think about this. It's a static library. That's what gets built. That PKG folder contains what? .a files, Go-based static libraries. If you really think about it, Go is kind of forcing microservices against our source tree, isn't it? Think about it. Trying to say to you, look, these things have to be decoupled. We cannot organize source code anymore in folders. What we have to do is think about organizing our APIs. And in Go, you cannot ignore this. Yes, other languages give you the ability to write static libraries. You could absolutely write code in C and other languages like this, but it's an option that comes with tooling, not the language itself. And this is what's happening. We don't recognize this coming out of the gate. We're trying to write code the way we used to. We are being successful. We're getting code out there that is deployable, but eventually we stumble. The project gets too big, there's too much coupling, and now we're back to trying to refactor things. All packages in Go are first class, right? Every time I hear somebody say, oh, there's a sub-package there, I cringe, because there really isn't technically sub-packages. The hierarchy is a relationship that we're creating. From the compiler's point of view, everything is flat. Everything is flat. But I don't want to lose this hierarchy. There's got to be ways in order to be able to bring it into our design to make our code readable, our project structures readable. And because each package is a static library, it is this firewall. There has to be ways to open it up. And that's where we get into exporting and unexporting, right? Those levels of language mechanics that we have here. And the cool thing is 2 packages cannot cross-import each other. Some people, when they first come to Go, they're like, why can't I do this? I like to think of this as Go slowing us down and saying to us, listen, dependencies are a real issue, and you have to think these things out. And that's what I see over and over again. We're missing our ability to think these things out in a clear way. Okay, those are the language mechanics. I haven't taught you anything new. I probably won't teach you too much new tonight. I want you to be thinking about these things. Now, we've got these language mechanics. We know how packaging works. We've all suffered through this a little bit, especially when we started. I want to now start talking about design philosophy around packaging. What should we be thinking about when we're building and designing packages? For me, there are 3 categories. Here they are. A package must have purpose, it must be usable, and most importantly, it must be portable. So what does it mean to have purpose? We're always told a package must provide and it cannot contain. What does that mean? We must be able to always say, hey, you got that, Ethan, man, you got that package? What does it do? What is it doing? If you can't tell me what it does, if you can't describe what it provides, we have a problem. The name of the package should also be very clear on what it provides. We're always told HTTP, IO, FUMPT. These are great names for packages because they describe exactly what they provide. And you've probably heard, don't use util, common, helpers, don't do this. These are packages that what? Contain a dumping ground of concerns. And why is that so bad? Because they become a dependency, a large dependency throughout your project. And eventually you're going to want to break that project up, and you can't. And so this is why I want you to focus. The first thing, when somebody on my team says, Bill, I need to write a new package, I'm going to say, why? What does it provide? Why? We don't have this already. We're going to have that conversation. They already know the answers before they come to me because they know we're going to have this conversation. 2, usability. Packages must be usable, right? What does that mean? Intuitive and simple. That is really abstract, intuitive and simple. But when you're writing your unit test, you should be able to validate that. The average person on your team or the average person that's going to use this package should not be struggling with it. The average person. You'll know that I know all the time because I'm the average developer. If I'm struggling with it, we know we have a problem. Now, this is one I see missed all the time. It really makes me sad. Your package must respect the impact it's going to have on resources and performance. I can't tell you how many APIs I see that might even be called in a tight loop, and every time I call it, it allocates. I know it allocates. It's very, very, very clear. Maybe it's returning a slice of something, a slice of bytes where the length of that backing array is unknown at compile time. And you put that inside a tight loop. Allocation, 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 allocation. Where does performance come in our software? Part of it is reducing pressure on the GC, and now I want to use your API, and I know if I use it, it's going to put pressure on it. All because you wouldn't allow me to provide you that slice. You felt like you had to return it back to me and create it yourself. We need to have some high-level understanding of escape analysis so we can design APIs that respect my application, because then I can't use your API. Okay, what else do we got here? You got to protect that user's application from cascading changes. What does that mean? Why do you think we use the error interface and interface for error handling? Why do you think we use an interface for error handling? Why do we stress not cause your user to have to perform a type assertion back to the concrete to do error handling? Why do we do that? Because if error handling is done at the interface level, then I can make improvements to those concrete types underneath, improve error handling without your code breaking. Think about it. The JSON package, unfortunately, can't do that. They use concrete types. But if they went ahead and changed anything on those concrete error, those error types that they have, a lot of code's going to break. A lot of code's going to break. A lot of people use the op error directly. It is an exported type. You can use it. But what does the op error type have? A temporary method and a timeout method. We stay and focus on behavior. We will not create cascading changes up. These things are really, really important. Reducing, minimizing, and simplifying our code all the way through. Okay, usability. Portability. This is the big one you usually hear about packaging, right? Portability. Depending on the package, I should be able to pick it up and move it just like this and use it. Let's think about packages as something physical that we can pick up and move when we need to. We must aspire for the highest level of portability, but this means where this package exists in our ecosystem, because depending on where it exists, it's going to have different constraints. And this is where package-oriented design is going to help you. Opinions, opinions, opinions. Oh my God. Let's say I wrote a package for configuration. And let's say I decided that this configuration package is going to log a certain way. Let's say you don't want to log that way. Let's say you don't want to use that logger at all. Can you now use my configuration package? No. Again, depending where this package exists in your ecosystem will depend what opinions it's allowed to have, allowed to enforce on others. This is critical. But again, it's all going to come back down to a project structure allowing us to determine what these constraints are. And again, don't become a single point of dependency. I see so many developers coming to Go, and they build that package of common types. Sounds like a good idea. This is what we've been taught to do. Why am I going to have duplicate types? I've got all of these things that need this type. Let's create this one common package, and we'll all depend on it. No. What I want you guys to do is the following. If you guys are on the same team and you're building a service and you're building a service and you're building a service, you're writing it in Go and they're writing it in another language. I do not care you're in the same project. I don't care if you're in the same company. You must always believe that you are writing in Go and everybody else is in Java, suffering. Because if you don't, You will create these common type systems. You will create these dependencies that in the beginning make you feel like you're moving fast, but eventually when that project gets too big and you want to break these things up, you can't. And now it requires a major restructuring. I want people to be successful using Go because I love this language and I want to use it. But if people are failing, or projects are failing, or projects are having to get restructured, that's at a moment in time where somebody in management can say, well, if we got to rewrite this thing, do we still want to do it in Go? Right? I've seen it happen. I've been on projects where they switched to Node when this happened. Why? You know why they switched to Node? Because they felt that they could get to where they are now in half the time. It was no longer about architecture. It was no longer about design. It was about what? Time. That's what it was. I don't want to see this anymore. So I really want us to start thinking. I am focusing all my efforts this year on design. If I see one more blog post about slices, I'm going to cry. We've written about language mechanics. It's out there. What we need is design. I need everybody in this room to start thinking about their design philosophies, sharing it with the community. We're now at that point where this is what we need. Now, I want to share with you my project structure and my approach to this. My project structure is designed for one thing: communication. So you and I can have a conversation one day about a package that we need and where it belongs and where it lives so we can all move in the same direction. How beautiful would it be if everybody in this room actually had their own project and we were all doing things the same way, having the same conversations, being able to talk to each other, and if somebody moved from one project to the other, they wouldn't be completely lost? How brilliant would that be? How amazing would that be if you switched jobs at a company? You could hit the ground running because you know from a project structure the rules on what is there, why it's there, what it does. How amazing would that be? How much more code can this community build and build better? So let's talk about this project structure that I have. I believe that every company should have a project called Kit, and a project is bound to a single repo. And the Kit project is your company's standard library. Go has a standard library. Guess what? You have a standard library. And this standard library provides foundational packages that all application projects are to use unless we agree there's an exception. Now, if you look at my Kit project here, it has some basic packages that you would probably find in any kind of standard library for a company. Config, log, pooling, GCP, web stuff. There's some rules here, however. These packages have to have the highest level of portability possible. What does that mean? That means that the log package cannot import the config package or vice versa. Maybe you want to use config, but you don't want to use this log. Maybe we've decided there's an exception on this project to have its different logger. If I bind log to config, can you use config? No. Highest level of dependencies. So how do we achieve this? There's one simple rule. Two packages at the same level cannot import each other. That's it. And if you feel like that relationship has to exist, then that package falls underneath. We use the hierarchy of the project to show import relationships. Two packages at the same level can never import each other. That's it. So how do we know we need a Kit package? Because this package has to be used across multiple projects. Brilliant. Now we have the highest level of decoupling that we need. Now, application projects. Again, a single repo. For me, an application project contains one or many binaries that are being built and deployed. They don't have to always deploy at exactly the same time. Our CI servers are pretty sophisticated. But a team of people working on a set of binaries, services, background commands, CLI tools, I don't care. They're all part of that same maybe platform, belong in this one repo. This is it. Now, what's brilliant about this is everybody's in the same boat. I can't tell you how many projects I've walked on where 3 developers, 3 services doing all different things. This developer wants to log this way, this developer wants you to configure this way, this developer wants you to do this, and now when it's time to deploy, it's a total mess. In those situations, this is where I go. I take all 3 developers, we put them in this application project, we now set standards for logging, configuration, anything. It's the application project itself sets the rules on opinions. So what are these 4 folders, basically? This is at the root of the repo. Command. Command's going to contain a folder for every binary that we're building. Separate folder for every binary that this project builds. Internal. What is internal? I told you that the Kit repo is what? The standard library for your company. You know what internal is? It's like the standard library for this application project. All of the binaries that have packages that need to be reused. Packages that need to be reused inside this application project, they belong in internal. Now, why am I using internal? Because the compiler respects this folder name. The compiler will not allow another project to import a package inside this internal folder. What did Brian say? That the language wasn't giving C any support? Here's another extra level of language support. When we say these packages are internal to this application, guess what? The compiler says, no problem, I will respect that. That's why I'm using internal. It enforces that down to the language. Vendor, we know what vendor is. And by the way, your Kit packages belong in vendor. And platform is under internal because I want the compiler protection. And those are foundational packages like your database support, maybe some web support, those types of things as well. But I've got a bunch of rules here that we can leverage against these structures to validate that what we're doing is sound and clean package design. So let's talk about some of the validation rules that I have here. We want to validate the location of every package before we write a single line of code. I've told you now here, Kit, foundational support for all the different application projects. Command, just packages specific to one particular binary. Internal, the packages that are reusable within that project, and platform, those foundational. Validate dependency choices. Now, regardless of where the package belongs, we always have to validate the cost and benefit of every dependency. We're not going to get away from dependencies, but we need to understand what the cost benefit. I always tell people all the time, it's never about right or wrong. It's always about what cost are we willing to take for this benefit. It's never about right or wrong. If you're doing architecture, if you're doing sound engineering, then you're weighing the cost and the benefit of every decision all the time. So I'm not saying you can't use dependencies, but let's validate and justify the cost because dependencies come with a large cost. Question imports for the sake of sharing existing types. Oh my God. Why are we doing this import? Oh, because I needed that type over there. What? You know, a little copy and paste can go a long way, and now I don't have this dependency anymore. Right? What's the problem with that? Again, I want you to almost think that every package is written in its own language. The more we can decouple now, the better you're going to be when this project gets large. I already said at all times, regardless of where you are, packages at the same level should never import each other. Use the hierarchy tree. If you are struggling, I've been in a situation where it's like, well, Bill, this package here needs this package here. Why? Because of this. Well, why don't we add another package above it? Maybe that package belongs in command because the functionality you need is very specific to this binary. Now I don't have to do the import here. The import happens where? Oh, I have the decoupling. So we need to be thinking about that. That's if a package must. Internal packages have some special rules on top of that. Any package inside of internal cannot import a package under command. Cannot go in that direction. Those command packages are what? Specific to that binary. If you see an import going into command, we have a problem. We cannot allow it. Think about all of these rules in a code review. Imagine we sat down in a code review with these rules in place. We all could do that code review and be constructive across the entire company. Internal platform. If you have a platform package, it cannot import into command, it cannot import into internal. That is the wrong direction. We have these rules in place. Opinions. I've talked about opinions. Opinions. Your internal platform and your kit, these packages are not allowed to have opinions about application concerns. They're not allowed to log. I know that's a big one. Guess what? Kit packages, not allowed to log. Platform packages, guess what? Not allowed to log. Well, Bill, I have to log. Oh, you can log before the call, couldn't you? I mean, we're not putting logging in the standard library, are we? Really? No. There's a little bit. There's exceptions to every rule, and when the Go team makes an exception, it's usually the right one. Let's just stay there. So these packages should not log because logging is a very big opinion to place on a package that needs to be reusable. Configuration and runtime changes must be decoupled. Metrics and telemetry must be decoupled when these packages exist here. Now, packages in command and internal, they're absolutely allowed to have opinions. They're part of an application that must be opinionated, and that's okay. But you got to remember something. There are times where you might have an internal package that you realize is reusable across multiple applications, and now you want to move it to where? Kit. Now you might have to refactor that to pull out logging, to pull out those types of things. We can have a whole conversation about logging and error handling, but right now we're going to focus on these rules. Validate how data is accepted and returned. When we're looking at the actual APIs associated with these packages, I want to make sure, this is a big one for me. I can't tell you how many times I see an inconsistent use of value and pointer semantics for a given type. If I see methods where there is a mix of value receivers and pointer receivers, then I know that this developer is not thinking about this type appropriately and the semantics that should be applied. If you can copy a value, then let's copy it. If it must be shared, let's share it. Think about the time package. Time values are based on value semantics. The add method takes a value receiver, returns a value of type time. Value, look at the time package and look at the consistency for the value semantics for time. This is a big one for me. Using an interface to accept a value. We're all taught to use interfaces to decouple. But when we're doing this, the focus really should be on the behavior we need, not because we need some state. Data can have behavior. Data can expose a capability. And most of the time, when a piece of data does that, it's because we're implementing what? An interface, most of the time. So if I see that interface, I'm going to ask, what exposed behavior am I looking for here? And if the answer is none, I just want to pass this piece of data in generically, there are reasons to do that, but we're going to talk about it. We're definitely going to talk about it. Now, if behavior is not required, use a concrete type. Understand something, cost-benefit. You understand there is a cost to using an interface, right? When we use an interface, there is an indirection that has to occur to make that method. When we need the decoupling, we will take that cost all day long. I will take that cost all day long when the decoupling is adding value. But if that decoupling is not adding value, then why would we take the allocation and the indirection? Seriously, why? I can't tell you how many times I've looked at a developer and I say, why is this interface here? Oh, Bill, because we have to use interfaces. No, we don't have to use interfaces. We use interfaces because they add value to our code. So what is the cost benefit that's going on here? And always question when we have types from dependencies leaking out of your exported API. If you take a type from a dependency and make it part of your exported API, you've now decoupled yourself almost for life. Think about it. What if you want to switch that dependency out for something else? Can you do it anymore? Let's say the dependency is MGO, the Mongo driver. And now I'm returning MGO types out of my exported API, and I decide that I want to use Cassandra. And now I got to break the entire API. Why? Because I exposed a type. Why? Because I didn't want to create a type that gave me that level of decoupling. These are things that I'm looking at all the time, and I want you to start thinking about during code reviews, during package API design, as a team, and leverage a project structure like this to give you that. And error handling is close and dear to my heart. Now, I understand, I'm going to just have 5 more minutes. I understand that logging is a contentious issue right now. But I already said not every package has the right to log. I really believe that. I also believe that logging as an insurance policy in case something happens is also very bad. I love this language, but because of escape analysis, most logging APIs are going to create a large number of allocations. It's going to put a lot of pressure on the GC. So from a Go perspective, I only want to log when there is something actionable to deal with and leverage metrics to the extent I can to show and indicating counts on things that I should be aware of. Dave Cheney wrote an amazing errors package, which will allow you to minimize all logging down to error handling. If this function down here has an error and doesn't want to handle it, wrap that root error, pass it up. Do you want to handle it? No. Wrap it and pass it up, because every time we wrap it, we're going to get a context for a call stack, and we're going to add extra context. Do you want to handle it? No. So what does handling an error mean? It means I'm not passing the buck up. It stops here. And as soon as we decide the error stops here, what is the first action we take? We log it. How simple is that? Think about it. We're all on a team, and we're looking at code, and we see a log call for an error, and we know immediately if I see a log call for an error and I see the error being returned, that's a bug, right? It's a semantic issue. Either return nil, okay, or don't log. We can all catch these things in our code. Now, I understand some applications have different logging constraints. It's not for debugging. But when we can say that our logs are for debugging, and we do these types of things, you're reducing all of that pressure. Remember cost. I will take the cost of those allocations all day when there's an error. Because not having the context is worse than what? The error itself. And if you're throwing that many errors while your software is running, well, we got other issues to deal with, don't we? So think about how wonderful this error handling can be. So that is what error handling means to me. It is no longer a concern. There's no more action to be taken, and it's logged if necessary. And again, then I come back to and I say this. Your kit packages, hey, they're not allowed to panic an application and shut it down. They're also not allowed to wrap errors. They're like that standard library. They must return root cause errors only. Command, absolutely allowed to panic. Absolutely allowed to wrap errors. But the majority of your error handling is going to happen in packages inside of command. The majority of them will happen there because that's that highest level of your application. Internal, not allowed to panic. Wrapping errors with context if you're not going to handle it. And you might do some error handling there inside of internal. And platform is very much like Kit. What I've just done here is given you a little bit of history on why we have packaging in Go. I've shared the language mechanics that most of you already know. And I've come up with a project structure that allows us to apply these design philosophies to what we're doing to give us the best opportunity to architect and structure our code as well as we can in the beginning. So when that growth comes and that team grows and we need to break things up, that we can do it with minimal to almost no pain. You don't have to agree with my project structure. I'm okay with that. Come up with your own. What I do want is whatever you come up with, share with the community. Bring your philosophies to it. Teach us how to validate design against it. Every project is different, different constraints. We can have lots of these types of project structures and validation structures in place. This is just one. This is working for me. I work on lots of client projects. This is working for me. My clients who incorporate this tell me they're having so much more success just on the communication that the team is having. And that just always makes me feel really good. Because then I know that the team is moving in the right direction. They're making the best decisions for today, and then they can deal with tomorrow. All right, thank you.
I don't even want to ask y'all because you haven't had any, but do you have any questions? All right. Do you have? Okay. I would love for all of us to be here and to bond together. You know how I love to bond with gophers. No, we really do. But we can't. We have to get out. So we promised them we'd clear out, and the elevators are going to take a little while. So if everyone could do a little housekeeping and clean up any trash around you so our lovely hosts don't have too much to clean up and they invite us back. And I really look forward to seeing y'all the next time. Thank you.